Hey everybody. So in this video we're talking about irrational zeros. So in this particular problem they want us to list all possible rational zeros and then find all the real zeros. So in order to find all the possible rational zeros we're going to have to use the rational root theorem. And the rational root theorem says they want you to list out all of your factors of your constant term and divide it by all the factors of your leading coefficient. So you may have seen this notation before, P divided by Q. P is going to be all the factors of your constant term, 36, while Q is going to be all the factors of your leading coefficient, in this case, 1. So I'll come down here and we'll write out all of our factors of 36. So that would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 18, and plus or minus 36. Now, normally what you would do is you would divide all of these by all the factors of your leading coefficient. But in this case, our leading coefficient is 1. So if we wrote out all of these and divided it by 1, we're just going to get the same number. So what the rational root theorem tells us is that one of these values is going to be a root or a solution to this polynomial. So this was really convenient when René Descartes discovered this because obviously they didn't have calculators. So instead of thinking about an infinite possibility of numbers that could represent solutions, we have now narrowed it down to just the factors of 36. So these are all the possible solutions, but they want us to find all the real solutions. So what we'll need to do is we will need to determine which one of these is a zero in the polynomial. Now, what I recommend doing is using a calculator to find out which one of these factors is a solution. So here I've pulled up my calculator, and what I'm going to do is I'm going to come up here to y equals, and I'm going to type in my equation from the problem. Okay, now that I have this, I can hit graph. And I can see where all of my solutions would be. So I know that I'm going to have a root here, and a root here. Well, we don't know what these values are, but we have an idea, and we think this is probably going to be a whole rational number. So let's see, if I hit second and graph, that brings me up to my table. And then I can see right here at 2, I have a y value of 0. That means 2 is going to be a root here. So if I come back to my problem, and if I know 2 is going to be a root, then I could use synthetic substitution to figure out the remaining factors. So I'll need to use the coefficients from this polynomial. So I'll use 1, negative 2, negative 18, and 36. So I have 1, negative 2, negative 18, and positive 36. So we'll come down here and complete synthetic division. So 2 times 1 is 2. We now need to add, so we're going to get 0. 2 times 0 is 0. Negative 18 plus 0 is negative 18. And then 2 times negative 18 is negative 36. Now this last part here, this is important because if this remainder is 0, then that means the number you plugged in is a solution to this problem. So that means it is indeed a root, which we already know because we saw that on the calculator. So if we were writing this out as factors, remember positive 2 is a root. So the factor, I would need to change the sign here. So I'm going to say x minus 2. And then remember that with synthetic division, the power of your leading exponent goes down. So where this started at 3, the solution here is going to be x squared. There's your x term, and there's your constant term. So this would be x squared minus 18 since there's no x's. Now, I need to figure out what the zeros are going to be. So I need to set each factor equal to 0. So I'll do that over here to the right. I'll say x minus 2 equals 0, and then I could say x squared minus 18 equals 0. So when I add the 2 to the other side, here I get x equals 2. Here I get x squared equals 18. So I'll need to take the square root here. So this will be plus or minus the square root of 18. So those are your solutions. We have 2 and we have plus or minus the square root of 18. Now the notation here at the end, really it's going to depend on what your professor or what your teacher wants you to do. We know that the square root of 18 is the exact same number as this radical simplified. But if your professor or teacher wants you to simplify here, you need to think of the largest perfect square that goes into 18, which is 9. So this, you could say, is the same thing as the square root of 9 times the square root of 2, and then that would simplify to be 3 root 2. So those could also be your solutions. You could rewrite it that way. However, the square root of 18 and 3 root 2 are numerically equivalent, so it's perfectly acceptable to say plus or minus root 18.